Welcome back, ladies and gentlemen, to Earth Science. Look forward to talking about the next section of rocks that are found for Chapter 3. We just finished igneous rocks. Today we are going to discuss metamorphic rocks, the second of the three different types of rocks. Alright, let's go ahead and begin, ladies and gentlemen. So what does a metamorphic rock mean? What does metamorphic mean? That means a great change. Okay, so metamorphic rocks are formed when other rocks are forced into the earth, where they heat up, become pliable, they twist and fold under extreme pressure. Also, superheated and reactive fluids can also metamorphose rocks. So technically two ways of doing so. Or through, I would add actually a third one we'll talk about is meteorite impacts as well. Oh, never mind. It's right here. Sometimes meteorites hit the ground so hard that they too can change the rock. The word morph, as I mentioned, means to change. Meta means a great change. For example, a caterpillar metamorphoses into a butterfly. These are below are two types of metamorphic textures. These are really important. There are two ways, or two textures, two physical features that you can see, the textures that differentiate them from other types of rocks, since they look very similar. One's foliated, the other one is non-foliated. These two are shown here in the below features. Foliated means rocks occur when the mineral grains are aligned in a parallel fashion. This happens at depth, and when you have a rock in question that has many different types of minerals, each mineral has a different melting point. Therefore, the grains start to become pliable, certain grains, and they tend to align and join together, creating bands of like minerals, forming these squiggly lines, parallel, not straight, but still parallel. Also known, this is known as a metamorphic texture. Very common. It's the best way to identify them. Non-foliated is not so easy. These are when they have no alignment of mineral grains. They're a solid mass. If you look at them, they're very, very tightly packed together. You really can't find an edge of the different grains of sediment or whatever that mineral is that you're in contact, or I should say the crystalline structure. You can't find the edging to it because it's been forced, or I would say almost forged together at depth. So all metamorphic rocks have what is called a parent rock. Okay, this is the next piece that's really important. Parent rocks. That basically means, the meaning of parent rock is, where did that rock come from? So it's a metamorphic rock now. Where did it come from? For example, quartzite here. Notice how it's literally forged together. Its parent rock used to be sandstone, which is very crumbly, easy to break apart. How this happens is sandstone is driven deep in the earth, oftentimes due to tectonic activity, and the mineral grains are squeezed together, pretty much, which makes it quartzite. So below, as I mentioned, this is the images of this example. This is the primo of primo examples. Shale is clay compressed into a sedimentary rock. That sedimentary rock, once you bury it, goes through 4 different stages of metamorphism. It first goes and turns into slate. You guys have probably heard that word before. It's also used as a color. It's a dark gray color. It breaks off in sheets. The first step of metamorphism. Second step, and also very dull. There's no main real minerals visible. It's very dull in color. Once it moves on to the next step, it becomes a phyllite. This has a little shine to it. That means the mineral grains are starting to express themselves by due to the bonding of different elements creating that mineral, and starting to become visible visible to the naked eye. Once it continues to get shoved deeper and deeper, it turns into a schist. This is where you get this grandeur of a beautiful array of minerals, all expressed gorgeously on the rock, yet still loosely packed and not really well cemented. They are, but not super strong yet. And if it continues to get suppressed deeper and deeper, it becomes a gneissic rock. This is what you make by and large, your countertops in your kitchens are made out of. It's a very, very, very hard, compact rock that has no real edging, so it doesn't weather very fast. So its parent rock of gneiss would be a schist. Schist's parent rock is phyllite. Phyllites to slate, slates to shale. Does that make sense? And the original parent rock of this is this. Okay? All right. Don't forget parent rocks. Now, there are two types of metamorphism. You can have one due to contact, or I should say, is contact, and the other one is regional. By definition, contact metamorphism occurs adjacent to the magma bodies. So this is a magma body deep underground, all molten rock. The edges, where it is in contact with the local rock, okay, or the natural rock, it changes this rock here because it's so hot it's not quite melting it, but it's altering it. Once it alters it, it becomes metamorphosed. That's called contact. Okay. It occurs because the magma body, as I mentioned, heats up the rock nearby. It becomes pliable but doesn't melt it. Therefore, it changes it. Another way you can do it, you can cause this, is due to meteorites. They'll have contact metamorphism right where it impacts the earth. That force and heat from that slamming into the ground alters the chemical composition of that rock. The second one is called regional. Regional metamorphism occurs in very large scale areas like mountain ranges. As mountain ranges are being formed, big blocks of rock called plates slam into each other, creating the pressure and generating the heat to bend and fold rocks, causing mineral grains to align. So basically, large continental collisions will create this. So Himalayas, for example, that's another good example of collision on a large scale, causing these rocks in the middle to heat up and become pliable, thus altering and creating them into a metamorphic rock. Okay, ladies and gentlemen, that's all for the lecture. Your job is to either click on this link or go to the link in your Google Classroom. I'll have both of them here or there loaded, and you will do the following lab. You are going to use the following table below, using the internet and other resources, to find out whether a rock is foliated or non-foliated and what the parent rocks are. And remember, parent rocks are the original rock types of metamorphic rocks. Then find the dominant minerals that make up each rock, and there are about 8 or so metamorphic rocks. You will identify their texture, parent rock, and dominant minerals, and then answer the following 5 questions. You'll turn this in, so it will be your responsibility by yourself to complete this and then turn it in. Alright, thanks ladies and gentlemen. Hope you guys had a good day, and keep it up.